Welcome. If you're passionate about power systems, substations, transmission lines, and everything that drives the world of electricity, you're in the right place. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. Whether you're a student, professional, or just curious about how electricity powers our world, these videos will help you learn and stay updated. So stay connected with the world of electrical engineering.
First, we switch on the control switch of the circuit breaker to close it. This means we execute the closing operation of the breaker, and an NO contact associated with this closing switch will send a signal to the SOTF relay. As the circuit breaker physically closes, the auxiliary rotary switch rotates. Its NO contact becomes closed and its NC contact becomes open. From these NO and NC contacts, signals are also taken to the SOTF relay. Thus, one signal indicates the change from open to close, and the other indicates the breaker's closing operation. As soon as either of these two signals, or both, are received, since this is an OR function, the SOTF relay becomes actuated. However, the SOTF relay will not send a trip signal to the circuit breaker until it also receives a fault signal from the CT and a low voltage signal from the VT. If a fault persists in the system, then as soon as the breaker closes, the CT secondary sends a fault current signal to the relay. Due to the high fault current, the line voltage drops, and the VT sends a low voltage signal. If either of these two signals or both are present, an AND operation takes place. Since the SOTF relay is already actuated and it receives the fault signal from the CT and VT, it will send a trip signal to the circuit breaker, causing it to trip and isolate the fault. On the other hand, if the SOTF relay is actuated but no fault signal comes from the CT and no low voltage signal comes from the VT, both are false, then the SOTF will be deactivated after 500 milliseconds and will reset, ready for the next operation.
Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.